All right, so we're starting a new unit, and the good news is a lot of this is review. It's stuff that you've seen, you should have seen, 7th grade, 8th grade, 9th grade, your sophomore year, your junior year. This is all stuff that kind of gets repeated. So we're just going to go through a quick review of what these different definitions mean, and hopefully you pick it up pretty quick. So what we're talking about is kind of characterizing all of this data that we're being presented with. So the first thing that it wants us to address is the distribution. So the distribution is kind of the value of the spread of all of our data. Okay, it's how the data is distributed, and we usually use like a display to show this, like a table or a graph, which we talked about a couple sections ago. So if you have your data being represented by a histogram, that's just showing you the distribution of the data. Okay, you're saying that there's a lot in this category, there's not as much down here. It's just the way the data is spread out. Okay, now when we look at this distribution, we have all sorts of mathematical ways that we analyze the spread or the distribution of the data. And some of these you've been using for a long time, like the mean. Remember, the mean is kind of our most common word for average. And that's where you take all of the different pieces of data, you add them all together, and you divide by the total number of values that you added together. So down here on example 1, it gives you 8 grocery stores sell the PR energy bar, and here's the price. So to find the mean, you would add all 8 of these together and then divide by 8. Okay. I'm not going to take the time to add that up on a video. I think you can handle adding. Actually, you know what? Let's do it this way. Let's go to our calculator. If I go to stats, if I click this stat button, there's an edit option. And if I hit enter on edit, it gives me some options for a list. And if I go ahead and I'm going to clear out this list, L1 right here, I'm going to hit clear, and I'm going to fill in all of these data points. So 1.09, and then we are going to put 1.29 and 1.29 again, 1.35. The nice thing is these are already in order for us, 1.49, 1.59, and 1.79. 1.79. So if I put all of this data in the list, I can get my calculator to not just find the mean, but it can find a lot of stuff for me. So first thing I do is make the list of all my data. And then if I click on stats again and go over to calculate, I want one var stats, and I'm going to hit enter. And then it asks what list I want to use. If you don't have list 1 here automatically, you hit second, and the stat button gives you all the different lists that you can choose from. I want list 1. So I'm going to hit enter, calculate, and it gives me a lot of information based on those numbers. And the first one that it gives me right here, this X with the bar over the top, that represents the average. Okay, so my mean. So my mean is going to equal $1.41. Okay. Now, as far as the median goes, the median you can find by scrolling down just a little bit. MED right here, 1.37. So remember, the median is the middle value. So the way that you've done this in the past, you put them in order from the smallest to the biggest, and then you kind of cross them out as you work towards the center. So I've got 2 in the middle, and I need the middle of the middle since there's 2. So in between $1.35 and $1.39 is $1.37, which matches my calculator right here. So my median, my value in the middle is $1.37. Now the mode, I don't think one var stats gives us the mode. The one that shows up the most, you're just going to have to look at and find on your own. And that one, it would be $1.29. And we really don't use the mode very often. We're not as interested in what happens the most as we are in what the average and the median are. Okay, so you're welcome to use your calculator to find that data for you. You can do it on Desmos as well. Maybe we'll go over that in class. But those are those three kind of are the different measures of center that we use to kind of find out, all right, where is all the data centered at? And the mean, again, is probably the most popular. And then the median, the mode, I don't think it's as valuable as a center because just because there's a lot of one piece of data doesn't mean it's necessarily in the center. But there's a good hint that it would be, depending on where you're getting your data from. All right, so moving on. Outliers. So here's what we need to be careful of is an outlier, remember, is a piece of data that doesn't fit within kind of the normal range. So looking at the data so far that we've used with these energy bars, the range goes from $1.09 up to $1.79. And what an outlier would be is, let's say that one store was selling this for 50 cents, which is way far from what the normal prices are looking like. Or maybe another store, maybe a gas station or something, is selling them for $3, which is significantly higher than what the others are. So these data points are called outliers. They're far away from that center, that middle ground that most of the data is clumped around. Now, what happens with these outliers is it can really skew the data that we're looking at. So the book gives us this example of, for whatever reason, they wanted to know what the average, where does it say? The average contract offer for college basketball team. So they take the 5 graduating seniors. So they have 5 guys that are about to graduate college on the basketball team. And they want the average NBA contract that they were offered. Well, if you look at the 5 individual numbers, 4 of them weren't offered a contract at all. And then 1 of them was offered a $10 million contract. So if I were to add these up and find the average, the mean, the argument is that the basketball graduates have an average or a mean of $2 million contracts, but really there's only one person with a $10 million contract. Most of them didn't get a contract at all. So these outliers can really skew our perception. They can give us this makes it look like, oh, a bunch of guys are making a small amount of money, but it's not. There's only one guy that's making a whole bunch of money, and then 4 people that aren't getting any contracts at all. Okay. So another example of this would be right here on number 2. A track coach wants to determine an appropriate heart rate for her athletes during workouts. So she takes 5 runners and they wear a heart monitor. In the middle of the workout, she reads their following heart rates. So 130, 135, 140, 145. Those all seem pretty reasonable, but then you have this 325 that is just way out there compared to the others. So in this case, if I were to take the average of those, that 325, what's going to happen is if I take that 130 and I add the 135 and I add the 140 and I add the 145, what does that get us? 265, 305, 350, 450. And then if I add that one in, now I'm at 875. So when I divide that by 5, we're at what, like 175 is the average. But look at my numbers, 130, 135, 140, 145. There's only one high one. So this average or this mean is a lot higher than what the data represents. This makes it seem like, wow, their heart rates are really high, when really there's only one that's super high, and that's probably because there was a mistake with the monitor. I don't think that this person's heart rate was really 325 beats per minute, because they would be having a heart attack. So in this case, rather than using the mean, because outliers can really skew our mean. So when there's outliers like this, usually the median would be a better option to use. Because if I look at the median, if I get rid of 130 and 325 and 135 and 145, that median is 140. And that looks a lot more like the center of my data. That looks a lot more like the average of my data than the mean does. The mean kind of gets skewed by those outliers. So whenever you have significant outliers, just know that that's going to skew your results. That's going to make your mean go one way or the other compared to the median. The median doesn't really get affected by those outliers because it doesn't matter if this is 325 or 150, it still gets canceled out when we're looking for the median because we're still looking for the middle piece of data. All right, so this quick review is already starting to add up a little bit. One thing that you may have not talked about much in your previous classes are these peaks, okay? So if I'm looking at this data now, these lines are kind of drawn in. I've just got these bar graphs, and these lines just kind of follow. If you notice there, it's connected to the center of each of the bar graphs. And it just kind of paints a picture of what the data is doing. So the data is going up and it kind of peaks and then it goes back down. This second set of data, as it kind of peaks and then it drops back down and then it peaks again and drops back down. And this third one is up and down all over the place. This looks like the stock market if you're looking at a short time frame. So what these peaks are talking about is when groups of data are kind of clumped together. So this one right here, this might be something like the average height of, I don't know, third graders. Okay, this might just be their average heights, and this is the number that are that height. This one in the middle, because things like that you measure, things like height and weight tend to make this nice curve where there's one peak in the middle where most people are, and then you've got this distribution where there's some people that weigh a lot more or are a lot taller, or there's some people that weigh a lot less or are a lot shorter, but most people are there kind of in the middle. This one in the center would be more of an example of something that kind of goes up and down. So there's not just one group together, but there's two different bunches that are kind of grouped. So looking at these examples, it wants us to say how many peaks we think there would be and why, and kind of make a rough sketch. So part A says heights of 1,000 randomly selected women. So if I made a sketch and I just took 1,000 random women, there's going to be some short ones, and then there's going to be a whole bunch of average middle height, and then there's going to be some tall ones. And the further out I go, the less tall, and the further to the left I go, the less short people I'm going to have. So I would expect there to be one peak if I was measuring the height of selected adult women. Part B, hours spent watching football on TV in January. So if I'm looking at people watching TV, so you're going to have some people that watch a whole bunch of football, and then you're going to have some people that don't watch a lot of football. But this one is probably going to have more than one peak because you kind of have two different groups of fans. I would say that you have just your casual fans, and then you have your super fans of football, right? So if I'm looking at just my casual fans, there's some that aren't going to watch very much football, and then you're going to kind of have your average amount of views. And then the casual fans, there's going to be some that start watching a lot more than their average counterparts. But then as we start getting into like the super fans, I think you're going to peak again, right? You're going to start getting, all of a sudden, you're going to have this group of people that watch a ridiculous amount of football. And then, of course, that's going to lower back down a little bit. So you're going to have kind of these two different groups, the average, just kind of low-key fans, and then you have the super fans. And each is going to have its own little bit of a peak. And I think that one is I could argue that one, that there may not be this dip in the middle. But that one's pretty opinionated, okay? Part C, weekly sales throughout the year at a clothing store. So if this is my number of sales going up the side. And then across the bottom, if we have our year. So let's say that this is like January, and then here's July, and then we've got December down here at the end. So I would imagine that in July, and maybe not even July, but maybe August, right about here, there's going to be some really high number of sales because of back to school stuff. And in December, around Christmas time, there's probably going to be another big bunch of sales. And then a lot of times around spring break, when it's starting to get warm and the weather's changing, you get a lot of sales. But in between, not a lot of people are buying clothes in February, right? And so you're probably going to get a few different peaks when we're talking about clothing sales, because there's a few different times of year that a lot of people are going to go spend money on kids' clothes. Now, the D is the number of people with particular last digit 0 through 9 in their social security numbers. Again, I would imagine the numbers of people with a particular last digit 0 through 9. Well, I would say there's not really going to be a peak at all because this seems like it would be pretty evenly distributed. You've got a lot of people that end with a 0 and 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9. There's not really a reason why there would be more of one than another. So this one, I don't think there would be any peaks. I think it would be just a pretty flat graph. I don't think you're going to have a lot of social security numbers ending with a certain value. Okay. All right, moving on. Left skewed and right skewed. I want to bring this one up because all the time I see it used backwards. All right. So what happens is on this left diagram, if there are a whole bunch of outliers over here to the left-hand side, if there's a whole bunch of low values, but most of the data is kind of bulked up here or grouped up here on the right, you want to call this skewed to the right because that's where the group of people are. But this is called a left skewed data because these outliers on the left, remember, if we have outliers, let's say that down here I've got one person with a 2 average of whatever, I don't know what it is, but then we have a whole bunch of people with 10s and then just a few with 12s. This 1, 2 is going to pull the average to the left. It's skewed to the left because of this outlier on the left. The data is grouped to the right, but the averages, the data, or not the data itself, the measurements that we're taking are being skewed left because of this outlier. And same with the right. If there's a whole bunch of outliers to the right, we say that our measurements are skewed to the right because of these outliers. They pull the data to the right, even if most of it's grouped right here, it's getting skewed right because of these outliers. And then a symmetric graph, the left and the right look the same. So the mean, the median, and the mode are right there in the middle together. And the left and the right are symmetric, or they're kind of like mirror images of each other. Okay. So example 6, for each of the following situations, state whether you expect the distribution to be symmetric, left or right skewed. So again, we're going to be dealing with a little bit of translation and our own experiences and opinions here. But the heights of sample women. So again, if I'm looking at the height of women, do I expect there to be a whole bunch over here on the right and then a couple random short people, or a whole bunch of short and a couple random tall? Or do we expect it to be symmetric? And I would definitely say that height, any measurement like height or weight or those sort of things, is usually going to be symmetric, okay? Unless I was measuring the heights of the basketball team, then it's probably going to be a lot more tall, but still maybe a little bit symmetric there, okay? B, number of books read during the school year by 5th graders. All right, so if I'm thinking about my own 5th graders, I've got 2 of them at home. And when school starts, everybody's really motivated and they want to work hard and they want to do a lot. And so in the beginning of the year, everybody's kind of reading. But then as time goes on, not everyone's going to keep reading as much. And you're going to have those few kids that read a whole bunch. But because they're in 5th grade and they have to read a certain amount for school, I would say that number of books read is going to be skewed to the right. I think you're going to have a whole bunch of kids right here, but then you're going to have those few kids like my son Briggs. He reads probably 3 chapter books a week as a 5th grader, which is going to put him way out here compared to most of the students in his class. He just really likes to read, so he reads a whole bunch. But because they're 5th grade students, you're not going to have a whole bunch of kids not reading at all, because that's not an option in 5th grade. That's a big part of what they're learning. And then C, speeds of cars on a road where a patrol car is using radar to detect speeders. So we're measuring the speed of the car. So I would imagine if you are able to see the cop car, what are most of us going to do? We're going to slow down. So we're not going to have a lot of data to the right. And then not only are we going to slow down, but we are going to slow down significantly. I bet there's a lot of people that slow down way more than they should just because they see a cop. I don't think you're going to have a lot of people speeding. And so I think this one's probably going to be right skewed as well. You're going to have a whole bunch of people going the speed limit or maybe even a little bit lower than the speed limit. And then you're going to have the few people, these outliers out here that aren't paying attention and don't see the cop to the right. Again, these are pretty opinionated. So if you feel like you have a different opinion, let me know in class next time. Okay, variation. So variation tells us how close together this data is or how widespread the data is. So if you look at these 3 graphs right here, we've got low variation when all of the data is kind of grouped close together. And then over here on the right, high variation means there's not a lot grouped. The data gets spread out over a large distance to the left and to the right. And then moderate is just kind of average. The data is kind of clumped, but then it kind of spreads out somewhere in the middle, right? So the variation describes how spread out, how spread out the data values are from that center. Okay, so if I look at example 7, how would you expect the variation to differ between times in an Olympic marathon and times in a New York marathon? So if I'm looking at these graphs and I'm looking at these thinking, okay, a New York marathon compared to an Olympic marathon. The Olympics are a lot of really good runners that run and run and run and run. You don't have these casual runners and you don't have these superstars because they're all superstars. So the Olympic marathoners are probably going to have a low variation graph. The data is probably going to be pretty close together. In fact, sometimes when you look at their race times, everyone is within fractions of seconds of each other, right? Especially on some of the shorter races. But if I'm looking at the New York Marathon, I've got the average racers that run a lot of marathons, but then I probably have some superstars that are really, really good runners that are running the New York Marathon, as well as some pretty casual people when you're comparing them to something like the Olympic group. So the New York Marathon, I would say, is going to have a lot higher variation. You're going to have the casual runners. Actually, it would go the other way around, right? The casual runners are going to take a long time because if this is time here at the bottom, you've got your casual runners down here. You've got your superstars at the front that are going really fast. And then you have the average marathon runners right there in the middle somewhere. Okay. So that's our variation. So from here, you are looking at homework 6A. If you want to start it at home, you are welcome to. We will be working on it in the next class. So if you have questions, we'll take care of those during class.